Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss introduction to bipolar junction transistors. Let's begin. In electronics, transistors are basically used in two purposes. One is switching in case of an electronic circuit, and another one for amplifying the signal. These two are the major functions of a transistors in electronics. So transistors are classified into two categories. One is bipolar junction transistors, termed as BJT. Next one, field effect transistors. FET. Here we discuss about bipolar junction transistors. The name bipolar means in that type of transistors both free electrons as well as holes are involved for the purpose of charge carrying. Bipolar junction transistor is named as both free electrons and holes are involved. So it is named like that. Bipolar junction transistors further classified into two categories. One is NPN transistors, another one is PNP transistors. Here NPN transistor is formed by taking that is consists of two PN junctions formed by sandwiching a p-type semiconductor between two n-type semiconductors. In figure we show it. In that PN junction, P type is sandwiched in between two N type semiconductors. In between two N type semiconductor, P type semiconductor is sandwiched. Then we obtain NPN transistor. Similarly, another type of bipolar junction transistor as PNP. In case of PNP, it consists of two PN junctions formed by sandwiching an N-type semiconductor between two P-type semiconductors. Here the N-type semiconductor is sandwiching between two P-type semiconductor. As a result, we obtain PNP transistors. Then question will come, is it possible as that N type is similar to this N type, again that P type is similar to this P type. So here another term we introduce, that is emitter base collector. That one is emitter, this one is base, this one is collector. Here emitter base collector, E stands for emitter. B stands for base and C stands for collector. The emitter, base and collector we can classify on the basis of their doping concentration as well as thickness. In emitter, it is highly doped, and that thickness is wider. Similarly, base, that one is lightly doped and thickness is very thin, very thin. In collector, that is moderately doped, and its thickness is much wider as comparison to that of emitter. It is more wider. Okay. For that reason, we can't change as that emitter as collector or that collector as emitter, because their construction is based upon doping concentration as well as thickness. In symbolically, we show a NPN transistor that is base, one is emitter, another one is collector. The emitter, base, collector, and an arrowhead is used. That arrowhead indicates the direction of emitter current. In N type, in NPN transistor, that arrowhead like this. In PNP transistor, the symbol base, emitter, collector, the base terminal, collector terminal, emitter terminal, emitter, base, collector. So here in PNP, the arrowhead like this from P to N. When we are dealing with PN junction diode, if that PN junction diode is forward biased, then it is allowed to flow the current. If it is reverse biased, then it obstruct the flow of current. Similarly, that arrowhead represents, that is Pn, this is P, that one is N, so P to N flow of current. Here N, P, so P to N is the flow of direction of current. Here NPN transistor, that one is PNP transistor. An important point here we can notice to show that arrowhead. That important point is in case of NPN transistor or PNP transistor, it is formed two junctions. Either that junction is emitter base junction or collector base junction. In transistors, we see two types of junctions. That are, one is emitter base junction, another one is collector base junction. When that transistor perform its function, we can notice that emitter base junction must be forward biased. It must be forward biased. Similarly, the collector base junction must be reverse biased. It must be reverse biased. On taking that important point, emitter base junction is always forward biased and collector base junction is always reverse biased. We can easily understand the current flow mechanism in case of NPN transistor as well as PNP transistor. In NPN transistor, one P type is sandwiched between two N type semiconductors. Here emitter, base, collector, and that emitter base junction is forward biased. N type is connected to negative terminal, P type is connected to that of positive terminal, negative, positive, and that voltage source is defined as, here is the emitter base junction voltage E B VEB. Then another junction, that is collector base junction. So collector base junction, which one is reverse biased? P type is connected to negative terminal, N type is connected to positive terminal, and the voltage of that collector base junction much more as comparison to that of voltage of emitter base junction in order to flow the current throughout that of transistor. For that purpose, we use two voltage source, much more voltage as comparison to that of VEB, voltage of collector base voltage. As it is forward biased, the majority charge carriers are electrons. Now the electrons move like this. Similarly, these electrons now overcome that base as that base is very thin and less doped, and the direction of flow of current that current is the emitter current I of E. Here the flow of current is the base current I of B, and there the flow of current collector current I of C, that is emitter current base current, that is the collector current. Emitter current, the sum of collector current plus base current. If the amount of emitter current increases, as a result we obtain more collector current as well as base current. This is the way how current flow in case of NPN transistor. Similarly, in case of PNP transistor, the flow of current mechanism is same as that of NPN transistor. Here is the charge carriers as free electrons, but there be the charge carriers are holes. PNP, emitter base, forward bias, P type is connected to positive, N type is connected to negative. That potential, emitter base potential. Similarly, that collector base, reverse bias, P type negative, N type positive, and that potential is much more as comparison to that of VEB. V collector base voltage, the majority charge carriers and the free electrons. Due to that of free electrons, current flow across that of here the majority charge carriers are holes. Due to that majority charge carriers, current flow across that of PNP transistor. And direction of current, that is the direction of flow of electrons. Look at that figure, that is not the direction of flow of current, that is the direction of flow of electrons, but conventional current flow the direction just opposite to that of electrons. The direction is just like this. Okay, here the direction that is the direction of flow of electrons, its opposite the direction of flow of current, the conventional current, the IE, IB, the IC. Similarly, emitter current is same as that collector current plus base current, that will be the current flow mechanism in case of PNP transistor. Here is the some basics of bipolar junction transistors. What is bipolar junction transistor? Is classification as NPN transistor and PNP transistor. How we show emitter, base and collector, its symbol, and current flow mechanism is holds good when emitter base junction is forward biased and collector base junction is reverse biased. And finally, we show the direction of flow of current as emitter current is the sum of collector current and base current. So, with this useful and informative notes, let me wind up this session. Thank you.